When talking about electronics, it's important to understand how power flows through the circuit. Let's start with the basics about voltage, current, and resistance. These three components come together in Ohm's law, which is the key to understanding a circuit. Ohm's law says V is equal to I times R, or voltage is equal to current, which is measured in amps, times resistance, which is measured in ohms. When working with the Arduino and a breadboard, we will be setting up circuits. A basic circuit is a closed loop with a source of electrical energy and a load, such as an LED. A load is anything that draws power. We want to make sure that we build closed circuits that offer enough resistance so we don't cause a short circuit. When you were young, your parents tell you not to touch the stovetop because it might be hot. Well, when dealing with circuits, the big no-no is connecting the positive directly to the negative side of a power supply, such as using the 5-volt output pin from the Arduino, connecting it to an LED, and then right back to ground. This is a great way to break a lot of LEDs in a hurry, and I speak from experience. This is referred to as a short circuit. To avoid this serious problem, we introduce resistors into the mix. It's important to choose the right type of a resistor. The resistor limits the flow of electrons. This resistance is measured in ohms, symbolized by the Greek letter omega. To find the correct resistor, you must know how much voltage is used up by all the components in the circuit. For example, an LED, our light-emitting diodes that we're using, they use up about 2 volts. Next, you need the amount of current. For an LED, this is about 20 milliamps. This information can be found in the specs for the LED. Now that we have that information, we can calculate the ohms needed in the resistor. Let's find the correct resistor value for a single LED. We can rearrange Ohm's law to find the resistor value by using R equals V divided by I. In our example, V is equal to 3 volts, since it loses 2 volts from the LED, and I is equal to 20 milliamps. So R is equal to 3V divided by 0.02A, which is equal to 150 ohms. Since we don't usually have a 150 ohm resistor, we can use the 220 ohm, which still allows for a bright LED. Note, we can use a higher ohm resistor, but we cannot use one that's less than 150 ohms without causing it to short circuit. Using this information, we can make a circuit schematic or a diagram. Use this diagram to correctly place the components on your breadboard. For more tutorials on basic electronics, specifically related to the world of microprocessing, check out Resistors 101, playwitharduino.com, ladyada.net, and learn.sparkfun.com/tutorials.